Welcome to Mission Critical, the Harting America's content series that offers our global audience of engineers the details they need to make informed decisions and provide inspired solutions. Today's topic is designing energy components to be future-proof. Let's dive in.
The biggest factors that are really common across the entire energy sector when we talk to our customers is going to be the speed in which they're installing things and the safety aspect. So when we look at speed and safety, what we're talking about is how quickly things are being built up in the grid, as well as how safely the grid is running and how safely the grid is being cared to by the technicians that are out on the field. When I'm talking with the different engineers in this sector, there's a lot of different needs that they're bringing to the table based off of their experiences. Maybe they've had corrosion issues, exposure issues that are a little bit different. Maybe they have a little bit more security concerns and they want really particular tooling that's used for the installation or for the disconnection of certain kind of connectors. All of those experiences really can indicate the kind of paths that they might want to take to designing some of the future upgrades within their grid space. We develop technology based off of the conversations we have with the data center industry to really make sure that things are being able to installed at the rate that is needed for a lot of these, especially hyperscalers, and being able to reliably connect that to the rest of the infrastructure needed to keep data centers up and running. Those users want to know what the safest products are for the grid, and it's really important that we are involved in the way that they are interconnecting into the grid as well. So that design process can be done as safely as possible and with a high level of reliability for decades of use to come. There are a lot of challenges that have come with this new data center demand on the energy industry. So being able to walk through that design process, both on the data center side, but also on the grid and equipment side of things, being able to have the conversations about how things are being tested, how they're being certified for the amount of power that's being demanded from the data center side, that's really critical. Not just for data centers, but also for the entire rest of the kind of end users to stay online, to have rates be, kept at a lower pace. Those are the kinds of things that are really critical within this space as we're addressing some of those challenges that have come from this sort of data center and AI boom that we're seeing right now. From a technology standpoint, on our end, we're really trying to develop solutions that make sense for a lot of those challenges we're seeing in the data center world, as well as the energy sector, trying to kind of meet that demand. Modularity in its largest sense is going to be the biggest way to future-proof a lot of the grid design that we're seeing out there. The biggest thing is that these data centers and these utility companies are in a lot of different environments, and so they want to be able to have options for the hoods and housings that are protecting those interconnection points on the grid. Being able to perform a lot of those upgrades, reduce some of the downtime on the grid side as well as the data center side, that's really important that we're addressing the environment that they're going to be in. For us, on our end, modularity really feels like the key to future-proofing the grid to ensure that any of the sort of future designs are being done in a way that allows for the continued growth that we're seeing. So how are we ensuring that we're keeping in mind any kind of PPE that's required, any OSHA kind of requirements as well? So are they wearing big gloves? Are they going to be out in the field in a really hot environment? And maybe it's safer for them to be testing some of this equipment offsite and then doing installations after the fact. How can we develop a roadmap that really meets the demand that we're seeing for a lot of this critical infrastructure? Utility companies cannot have their power go out. They lose customers, they lose their reputation. This is critical infrastructure. So the impact that our connectors have on any of the performance or installation is going to be really critical. It's really important that we're minimizing any kind of outages, but also any kind of downtime during those outages. Utility companies also are really noticing how important it is from a security standpoint and an engineering standpoint to work with localized partners. People who understand some of the demands that we're seeing out in the industry, being able to address them from a local perspective, and really doing the testing and work that needs to be done for future-proofing the grid is going to be really important on the local level. So whatever we can provide in terms of conversation in an engineering partnership or in the technology that we're providing to ensure that there is really minimal outages and really minimal downtime with that. Because of this, we have to ensure that we're testing our equipment ahead of time. We're working with them in the way that they're installing any of their upgrades, and they're ensuring that any kind of swap outs that might need to happen when there's an outage is minimized in the time that it takes. There are a lot of challenges that our equipment manufacturers on the grid are facing right now. And so it's really important that we're able to address the way that they are meeting those challenges in terms of the speed that's being requested for them, the kind of pressure that they have on their supply chains, and also the requests that they're getting from a technological standpoint. How are they able to address some of the questions about energy automation and the way that their safety protocols are helping the grid stay up and online in the safest way possible? Part of what the issue is that a lot of this equipment that they're trying to integrate into their total system is not plug and play. And so what happens is you're not able to integrate it into the way that it's installed and manufactured, and you're not able to test that equipment and be able to better optimize the way that it is installed. So part of this is being able to optimize the way that they're manufacturing their systems and installing their systems out in the field. That comes with being able to integrate a lot more into smaller spaces. So typically we see that in the footprint conversations that we have on our connectors. And we also see that in just moving from, the hardwiring the kind of old way to being able to have modularity and connectors in the way that you're doing that installation. Let's settle the debate here between rectangular connectors and circular connectors in the energy industry. When we look at the two, the biggest advantage that we're hearing back is that the modularity aspect that you get from rectangular connectors with these inserts, as well as the footprint savings that you're able to integrate a lot more of those automation and safety protocols within a particular piece of equipment. Those are the two most critical pieces and kind of advantages that we see within rectangular connectors. If you're able to add in certain features without having to change the footprint of the panel or the cabinet that you're integrating it into, that's going to be really critical for kind of future-proofing that piece of equipment. There are a lot of different options that we see within our rectangular portfolio for the energy equipment space. Looking at the HAN B that we see here, being able to integrate it in a panel mount or a cabinet kind of application, that's going to be really critical. Being able to have something that is shielded against corrosion as well, depending on the environment, or being able to have something that's going to be indoors, and that makes a little bit more sense for that piece of equipment. Navigating that before we go into the interconnection on the inside, that's going to be really critical. After you kind of understand what needs to surround the interconnection, you can go into the inserts. When we're trying to talk with people in the operating side of the energy sector, it's really important that we understand that technology adaptation takes time with how critical this infrastructure is. Being able to adapt to the changing demands that we're seeing out in the industry and in the grid, being able to understand that if something is lasting on the bottom of a rail car, it probably can last in a substation as well, but also being able to adapt our designs and develop alongside the concerns of those in the industry, that's a really critical part of building that trust in the energy industry. Being able to have these conversations and be able to prove our products have stood the test of time while also being able to innovate alongside our customers, that's going to be where we really shine within this space.
For more details on the contributions HARTING Americas is bringing to the energy industry, contact us today